Okay, continuing on with number 5. I mentioned in the first video that in this video, rather than just writing everything from scratch, I do have some prepared slides that have answers written just to save a little time. Okay, so question 5. If you notice it is a great way to approach this question by looking at factoring by grouping. So if you happen to notice that, then you can say, well, out of the first group, the GCF would be 3x squared, which leaves me with an x plus 6. And if this is a successful factoring by grouping, this has to be x plus 6. Is there something I can take out of these terms to have an x plus 6? Well, the first part looks like it would have to have minus 12 in order to have minus 12x, right? And then we need to think, well, is negative 12 times 6 negative 72? And it is. So now, out of this part and this part, both of those have a factor of x plus 6. So we could take that out. And then out of this part, we can take 3x squared minus 12. At this point, I just suddenly realized I should have taken out a GCF at the beginning, because right here, I have a factor that has a 3. So that 3 must have been around up here as well. Well, it's not too late, fortunately. You can still take out a common factor when you notice it, like I just did. And then this little guy over here is a difference of 2 squares. So I have 3, I have x plus 6, I have x plus 2, and I have x minus 2. So that's my final factored form. Now, that is not the only way to get to that answer. You might have also looked at a graph on your calculator and noticed that you had some really nice options for synthetic division, because for your zeros, you have x equals negative 6, and x equals negative 2, and x equals 2. And all of those would have just worked swimmingly in some synthetic division, okay? So my answer up here, by the way, is this part that's in blue. Okay, and then to find my y-intercept, I would think about what the function's value is at x equals 0, and that's going to be negative 72. And then we make the best graph that we could, and that would look something like this. Negative 72 is way off the grid, so just kind of draw a little sketch. You want to just get the gist. All 3 of the intercepts, or the zeros, are ones that the graph crosses through because they all had multiplicity of 1, because they were only in the factored form 1 time each. I often will make a little chart in my classes about roots and multiplicity. So if you look back at these factors, you'd have negative 6 and negative 2 and negative 1. They each were there just the 1 time, okay? All right, in the next question, it's again a lot of factoring by grouping. So we could have, at the beginning, noticed that there was a 4. Now, in this answer key, they did the same kind of thing I just did on the last question, and they didn't notice the 4 right away. But that's fine. You can take out the 4 when you recognize the 4 if you need to, okay? This one didn't actually say to find the factored form. This one just said find all the roots, which just means to find all the solutions, okay? So I'll just show you for contrast's sake what would have happened if we saw the 4 at the beginning. If that had happened, we would have taken out that 4 from each term. And then I still would have done factoring by grouping, perhaps, with these 2 sections. This has x squared and then x plus 2. If factoring by grouping works, this has to be x plus 2, which means I must have this 11. Okay, and so now my factored form has 4. It has x plus 2 factored out of each of these components, and then it has x squared plus 11. So there's my factored form, and it's said to find all the roots, so I want to let each of those factors equal 0. And this would give me the negative 2. And then here, this is going to be a pair of complex solutions, because you see x squared that equals a negative. And so x is going to equal positive or negative 1 times square root of 11. All right, so that's number 6. This is number 6 again if you didn't see the GCF at the beginning, just like I did on the other one, okay? This question is very much put together all the clues, okay? So I wouldn't worry about the questions at the end. I would only worry about the things that are in here. This clue looks like the easiest to put onto the picture because it's very specific. So I want to go up to 9. And put a dot right there. Okay, and that is complete. There's no other way to interpret that. I don't have to think about it anymore. Okay, this one actually looks pretty specific too, now that I look more closely. It has the only x-intercepts at -6 and -1 and +3. Okay, so that's that. Now the rest of this is a little bit more tricky perhaps. It says that there's a local min, so like a valley, at -6. 1, 2, 3, 4, 5, 6. Okay, so somewhere lined up here. It doesn't say how low it is. I'm just going to pick a point and kind of use that as a guide. And then it says we have, oh, it's a max. Excuse me. Holy cow. That was almost a big mistake. A maximum. So if I'm coming through here, then it would have to be higher than there. I'm thinking. Excuse me. And then a local max at 1, so maybe another high point over here, and then a local min at -3, so maybe like down here. So polynomials, which it says it is, are always smooth. They aren't pointy or have sharp turns or anything, so I just need to try to connect these as best I can. Oh, I have a little puzzle going here, don't I? It must not go that direction, because the only places I'm allowed to go through the x-axis are those red dots. Let's check out this for a second. That's the puzzle. Okay, so I need to get through, this is my local max at -6. I think I plotted something wrong. That's what I did. I plotted something wrong. Yeah, this is a helpful video, right? This is -6. I thought, you saw what I did. I just put them in 2 different places. Okay, that's -6, which is both an x-intercept and a local max. Okay, now things make sense. I was worried. Okay, so it says that the only x-intercepts are these red dots, so that's the only places I can touch the x-axis. So I must I could come through there, and then go to here, and then here, and then here, and then here, and then I could turn around here, or I could go down. I could go that way, and then I could go up like this or down like that. I'm not sure yet. And it said it had a local minimum at -3. Oh, heck, I haven't even done that yet. So at -3, I just botched this whole thing. Okay, I'm going to try this again in the next video. Bye!